In today's lesson, we're going to finalize lesson 3 from unit 3. If you were absent, you will find the handout in modules under the February 18-19 date. So to recap what we discussed on Tuesday, we were trying to decide or determine if I gave you a side-to-side angle situation, how many triangles were possible. So we started off by figuring out what value for A would create right triangles, and we found 2 answers for all 3 problems. There were always 2 answers, depending on where you place the length at. And one problem is always done with sine, and the other problem is always done with tangent. So, applying those 2 right triangle cases, what we found was that to the left of the first one, which in this case is the 4.5, the A value, or the side opposite the angle, was always small enough that it would never produce a triangle. And that was true for all 3 of the cases. And then after 4.5, we found that there were 2 triangles. That was true for all 3 problems. And then when we got the right triangle, we actually found out that in 2 of them, the right triangle was actually only one of 2 possibilities. So there actually was a second triangle, not necessarily a right triangle, but a second triangle. And that was true for the first 2, but not for the last one. The third case, the right triangle actually was only one possibility. And then we found that eventually we got to a number that we went back to 1 triangle, and that number was always the length that we were using from the angle. So when we got to 9, it became 1 triangle again. The second one, when we got to 7, it became 1 triangle. And the last one, when we got to 8, it became 1 triangle. So when establishing the rule here, we're only going to care about the first right triangle in our number line, which is always a sine problem. So all these were sine problems for the first point, because everything to the left of that answer was always produced 0 triangles. So that problem was done using sine. And to the left of that, there was always 0 triangles. So if A is equal to B times the sine of A, so they're equal to each other because of the sine rule. So sine is, when he said the problem sine of A is equal to A over B, if I cross multiply, I end up with B times sine of A equals A. I'd recommend for setting these problems up to test them, I would always recommend putting the opposite side first when trying to make the decision, not second. And so when they're equal, we have a right triangle. But when A was smaller than that answer, then we have no triangles. So that would be, if A happens to be smaller than B times the sine of A, then we're not going to have any triangles at all. After that, we got the 2 triangles, and that continued to be true until we got to the place where A and B actually were the same number. And then as A increased after that, we always end up with 1 triangle. So the last test is how does A and B compare to each other, and if they're equal or bigger, we had 1 triangle. So these are the rules. So so we have a rule for the 0 triangles, we have a rule for the 1 triangle, and the question I'm asking 16 is, why wasn't an incomplete rule provided for the middle region? And the answer is simply, if it's not a 1 triangle situation or a 0 triangle situation, and if it's not a right triangle to begin with, then there's only one case left, which means there has to be 2 triangles. So that's why there's no rule provided. And then which of the 3 rules should you check first? So should we be checking the b times sine of a? Should we just check to see if they're less? Should we check to see if a is greater than or equal to b? And I would recommend to you that you start with comparing a and b. A again being the sine opposite the given angle. And if a is greater than b or equal to b, then you're done. We know there's only one triangle. If it's not greater than or equal to b, then that means we are going to be looking at the other cases. So I'm going to kind of put a line here to split this up. So basically, if a is greater than or equal to b, we're done. There's one triangle. If that is not true, then I either have 0 triangles, 1 triangle, or 2 triangles, and that's all based on this rule right here. How does a and b times the sine of a compare? If it's less than, a is less than that answer, there's no triangle. If it's equal to that answer, the two are equal to each other, there's one triangle. And actually, if a is greater than b times the sine of a, then we're going to have 2 triangles. But if you do the sine of a first, then you may have a conflict between these 2 rules. Because if a is greater than that, which is 2 triangles, well, at some point, it's going to become 1 triangle, and you won't be able to determine that if you start with the sine rule. So that's why I suggest always start off with a is greater than or equal to b. So after problem 17, you're going to see the section called Let's Practice. And there are 5 problems there. So based on the conversation for the rest of the class, I'm going to try to set up what I'd like you to do here under Let's Practice. So I'd like you to figure out how many triangles exist, 0, 1, or 2, and then if you have any situation in which there are 2 triangles, I would like you to find both triangles, and that includes all the angles and all of the sides. And that's what we're going to be doing for the rest of this video and possibly into the next video. So going back to these problems here, which are not in your handout, so I'd recommend taking out your own paper, using calculator, pencil, and then turn the video back on when you're ready to continue. All right, so first thing I would suggest doing is always pair up the angle and side that are opposite each other, which means that we're comparing is A greater than or equal to C. That's that first step. And if that is a true statement, then that means there is only one triangle. If that's not true, then we're going to be comparing A to C times the sine of A. And the question is it less than? Are they equal? Or is it greater? And based on that, on which symbol goes in that space, that determines whether there's no triangles, one triangle, or two triangles. So, starting with A, 32 is greater than or equal to 19. That's a true statement. So that means there is only one triangle. So back to what we were talking about earlier, that situation would fall out here to the right of that point where A and B fall on top of each other. If you go ahead and take a look at problem 2 and 3 and go through the same steps and then turn the video back on when you're ready to continue. Okay, so I'm going to again pair up the side and angle that are opposite each other. So I'm comparing is A greater than or equal to C? And that's false. That I'm comparing is A, how's A compared to C times the sine of A? And what I'm looking for is, are they less? Are they equal? Or is A greater than C times the sine of A? If A is less than C sine of A, there's no triangles. If they're equal, it's one triangle, it's always a right triangle. And if it's greater, then it's 2. So this problem here, A is 25, C is 8. So again, this is another true statement. So there is only one triangle, which means it's going to fall off to the right, far right on that number line. problem 3. This time B is, side B is opposite angle D. So I'm doing a comparison of B compared to A. If that's true, one triangle. And I'm doing a comparison of B compared to A times the sine of B. And the same results, less than or equal or greater. It's less than 0, equal 1, greater than 2. So this problem here, 29 is greater than or equal to 33. That's false. So that means that in terms of our region here, we have our points here. This is where the one triangle exists, and this rule didn't work for that region. So that means we are now between in this other region. What we're looking at, is it 0? Is it 1 because it's a right triangle, or is it 2? So it's going to be somewhere in there. So B is 29. A is 33 times the sine of 100 degrees. And we're going to make a comparison between these two sides and decide how many triangles there are. Right, so 33 times the sine of 100 is 32.499. So that means we're looking at it's less than situation. So it's less than means there are no triangles. So that means for this situation here, that triangle, I mean that situation would be in the region where if you swung the arm for B, it would never hit the angle. So there's no triangle in that situation. All right, problems 4, 5, and 6. You go ahead and go through the same steps, see whether or not there's one triangle using the side opposite the angle compared to the other side. And then if that is false, then use the sign as the second part. And are the values is less than, greater, or equal, and it will determine how many triangles there are. Turn the video back on, and then I will go through all 3 of them. All right, so side opposite angle B is side B. So I'm comparing, is B greater than or equal to A? And if that's not true, then I'm doing is B compared to A times the sine of B. And again, there's my 3 possibilities here. So it's less than 0, equal 1 is greater than 2. So B is 32, A is 35, so this is false. So that means in terms of our place here where there's one triangle, that it's not there. So that means it's somewhere in here, where we have 0 triangles, 1 triangle, or 2 triangles, and that's where the sine rule comes in at. So 32 compared to 35 times the sine of 61 degrees. So 35 sine of 61 is 30.612. So that means it is greater than. So that means we have 2 triangles. So that means that answer would fall in here somewhere. So this one has 2 triangles. Problem 5. Side opposite the angle A is side A. So we're comparing A and C. And then that's false. Then we're comparing A and C times the sine of A. All right, so 9 is greater than or equal to 34. That's false. And then we're comparing 9 and 34 times the sine of 68 degrees. So we have 31.5, so it's less than. So that means we have 0 triangles. Okay, I'm going to stop here because I'm running out of time in the video. We'll pick up with problem 6 and the last problems for this lesson in the next video.